Good morning, friends. We are discussing now processing of n jobs through two machines. That is, number of jobs given will be n. So they have to get processed on the two machines. If the machines are given named as A and B, first the job should be getting processed on machine A, then it has to get processed on machine B. So n number of jobs through two machines. Suppose there are 5 jobs here A, B, C, D and E to be processed on these two machines 1 and 2. So uh, here the machine A or machine B, or it will be named as machine 1 and 2. So whatever is the job is taken, whether you take D first or A first or E first, it has to get processed on machine 1 and then it has to get processed on machine 2. That is machine A and machine B. So processing times are given in the table. So if it is in minutes, so we'll find out the total processing time in minutes. If it is in hours, it will be taken in hours. So determine the sequence in which these jobs will be processed so as to minimize the total processing time. So whatever is the sequence of jobs taken, so all the jobs should be getting processed first on machine 1, then it has to enter machine 2. So that all the jobs, I have to see that all the 5 jobs will be getting done on these two machines in the total processing time. Okay. First step, that is here we are following Johnson's algorithm of sequencing. So the concept of Johnson's algorithm is that if we have a number of activities in a project, so the human tendency is to start the project with a simple activity or the simple job which consumes less time. Similarly, at the completion, so we don't want to keep the activities which are very tough and are taking too much of time. So initially we want the project get started with simple jobs, and the finishing of the project will be made sure that it is completed with simple jobs. In the middle, we'll consider the difficult or the moderate jobs. Keeping that logic, so Johnson's algorithm follows like this. So first we want to take the job having less processing time. So out of these processing times given, the less processing time is 2 here. So that is on machine 1 for job B. So in the beginning, I want to take the job on machine 1 which consumes less time. So the least processing time is this 2. So that is on machine 1 for job B. So job B should be sequenced in the beginning. If it is on machine 2, I would have placed the job B in the ending of the sequence, because I want to take the job on machine 2 which is taking less time in the finishing. So initially I want to start my activity on machine 1 which consumes less time. So now job B is taking less time on machine 1. So job B will be sequenced in the beginning. Now in the coming iterations, I will eliminate job B because the position of job B is fixed now. So the reduced set of processing times of jobs will be like this: A, C, D, E with the processing times given here. Now we'll consider the next minimum processing time. So that is 3 here. So it is for machine 2. That means if it is on machine 2, I want to keep the activity consuming less time in the end. So that is on machine 2. So since 3 is on machine 2 for the job A, so job A will be positioned in the end. So B in the beginning, A in the end. Now the remaining positions we need to find out. Now job A will be eliminated from further consideration because already its position is fixed now. So after deletion of this job number 1, that is A, the reduced set will be like this CDE with these processing times. So following the Johnson's algorithm, so the sequencing is completed. So now the sequencing of jobs will be B, C, B, D, C, E and A. If we go in this sequencing, so the activities will be completed in a minimum total elapsed time. So on the basis of optimal sequence, so here the minimum elapsed time is found in the table as 36 hours. How we got this 36? We'll see stepwise. So the sequence what we obtained is BDCEA. So that sequence we have written here BDCEA. Then machine 1, machine 2. Each job has to get processed on machine 1 first, then it has to enter machine 2. So the first job in the sequence is B and its minimum processing time required, right? So that is 2 units. Maybe it is in minutes or hours, whatever it is. So that it is entering a machine 1 on the 0th hour. So the time given, if it is in hours, so it will be taken as hours. So it gets completed by 2 hours on machine 1. So I write 2 in timeout. So once it comes out of machine 1 on the end of second hour, it enters machine 2 on second hour. Then job B requires 7 hours of processing time on machine 2. So it is now entering machine 2 at the end of second hour. So 2 plus 7, so it is 9. So on 9th hour it is coming out. So idle time, machine 1 and machine 2. So the machine 1 is not kept idle. So it is the job is entering machine 1 on 0th hour. So idle time is 0. But machine 2 is kept idle because until this job comes out of machine 1, it has no work to do. So first 2 hours it is jobless. So idle time I will write 2 here. So then the next job D. So once the previous job B comes out of machine 1 on second hour, the next job D will enter machine 1 on second hour. So it get processed there for 4 hours. So it is 2 plus 4, 6. It is not entering machine 2 on 6th hour, even though it is processed on 6th hour on machine 1, because still the previous work is going on in machine 2. So the machine 2 is made free only at the end of 9th hour. So this particular job will enter machine 2 on 9th hour. So 9 plus 9, it is 18. So 0 idle time on the 2 machines. So likewise, so the table will be getting completed. So here we are getting 36 hours. So here for job E, so the machine time, machine 2 is having idle time of 1 because the machine is made free on 26th hour itself, but this job E getting completed on 27th hour. So it enters machine 2 on 27th hour. So difference of 26 and 27 is 1. So after all the jobs are over, so that is machine 1 get its work done on 33 hours. So 36 minus 3. So 3 hours. So this is 0. So total processing time is 36 hours and idle time on machine 1 is 3 hours and idle time on machine 2 is 4 hours. That is the summation of the columns. Thank you, friends.